um, maybe we can get started by talking about what's a model, right? I think that's interesting. Uh, so remember that data science and the world of science depends on models, and a model is just an abstraction of reality. So you need a way. I mean, you want to define a process, and the way you do that is you define a model in the way that you define equations, or you define a system that can represent the real thing you try to understand. You have to take some assumptions. This is not the case that we're doing this for the whole complete problem. We isolate some pieces of the problem, and we transform that into mathematical equations that then we can solve with computers. And that's the idea. I mean, the model in the world of science is not the same as the model in data science. In data science, you need a model that you can represent in the world of programming. So that needs to be a way that you need. I mean, you want to be able to transform that model into code, and then to fit your model means that you're trying to accommodate your model to your actual data. So that's the basic idea we have here. So maybe Andreas, you can talk a little bit more about an example of model here, maybe.
Um, I as the engineer,
Yeah.
yeah. So what from my experience, what I have experienced is that, for instance, people are. I'm coming from the IoT world. That they're creating basically models of how do machines work. Like you're taking measurements from machines, and then you're basically creating a you're taking all the data in, and you're building a um, could call this a twin or a model of this system, and then evaluate how good these things work. And then you have basically different states in that, and you then evaluate this on the fly when new data is coming in, for instance, for some stuff like predictive maintenance or something, you know.